Hi everyone, welcome. In this video I'm going to explain what Boxplots are, and then I'll also demonstrate how you can use Tableau to create one. So a Boxplot is pretty much a structured plot of your distribution. There are many ways you can plot your distribution to see where the data fit or where the data are in terms of their percentile proportion, and also to see where if your data distribution have any significant outlier or skewness. Histogram is one of the ways, and Boxplot is also one of the ways that you can use. Boxplots are more efficient because it also allows you to use the IQR to designate the outlier for both left and right tail. So this is a box plot, and this is the structure. There's no number embedded here, just for the sake of this demonstration. Again, a box plot goes from the minimum, which is the lowest value in the distribution, all the way to the maximum. So between minimum and maximum, there are the quartiles. So from the minimum to Q1 or first quartile, or the Q1, 25% of the data lies between the minimum and the first quartile, where the 25th percentiles ends, and the other 25% of the data of the distribution lies between the first quartile and the second quartile, which is also called the median. And then the other 25% of the distribution lies between the median or the second quartile and the third quartile. And then lastly, the last remaining 25% of your distribution lies between the third quartile or the 75th percentile to the maximum, which is the highest value in the distribution. So that's how you can look at the values to designate their percentile ranking, their percentile placement, where they are in terms of the distribution. So not only that, you can also, as I said, you can also designate what outliers are. But before I talk about the outliers, I need to explain what the IQR is. IQR is pretty much the 50% of the distribution, or the middle 50% of the distribution. And how you can find an IQR is pretty much you minus Q3, Q1 out of Q3. So in that case would be Q3 minus Q1 is going to give you the IQR. So again, the IQR, or the interquartile range, is nothing but the 50% of your distribution that lies between the first quartile and the third quartile, and where the median also lies just right in the middle of them. So to find the outlier in the distribution, there is a formula that's standard in the statistical calculations, and that is to find the outlier on the right tail of the distribution, meaning on the positive side. Pretty much use the IQR, which I just explained how you can find it, and you multiply that by 1.5. That's the standard 1.5, and then you add it with the third quartile. Let's say if the third quartile here was let's say 70, right? And let's say the first quartile here, let's say it was 30, right? So what you do is first you find the IQR. So in that case would be 70 minus 30. And then that will be 40. So 40 is now your IQR. So 40 times multiplied by 1.5 would be that would give you 60. So 60 plus your third quartile, which is 70 here, as you can see. So 70 plus 60 is going to be 130. So any number that exceeds 130 is in the outlier zone. That's how you can find the outlier on the right tail or the positive side. You can use the same formula to find the outlier for the left tail of the distribution or on the minus side. Pretty much use the same formula, except this time you you use that to minus from the Q1. So instead of you know using the IQR, which is 60 in this case, um, oh, I've probably made a mistake. Yeah, the IQR, which is 60 in this case, you minus Q1 out of 60, so that would be Q1 minus IQR times 1.5, and that would be Q1 is 30, so that would be 30 minus the IQR multiplied by 1.5, which is 60, so that would be 60. That gives us a value of minus 30. So if the value exceeds minus 30 on the left tail of the distribution, then that any value exceeding minus 30 on the left tail is considered to be in the outlier zone. So that's the way that you can find outliers. Very basic calculation method in statistics to find out. Now let's look at how you can actually create a box plot, also calculates for outliers in Tableau. So Tableau again has made a lot of statistical calculations very easy, although it's a visualization tool, but again it has a good amount of calculation features embedded in it that allows you to do advanced basic to advanced models. So to create a box plot in Tableau, you simply need to have a measured variable. In which case, these are measured variables, and I'm just using a data set that I was extracting for a different project. So I'm using that for the sake of this demonstration. So let's say age is a measure variable. So we're going to bring that onto the row shelf. As you can see, and by default, Tableau sums it up or aggregates it. So as you can see, the charts that are available in the Show Me has the box plot or box and whisker plot. That's what it's called. Tableau calls it, but in statistics, it's called Boxplot. The whisker is pretty much the whiskers that come with the box. So as you can see, it's not active. Why? Because our variable is in the aggregated mode. So while we need to first deaggregate the variable, and then we can just and then the box plot map becomes activated, and you can use that to create your box plot. And there you go. You now have your box plot. There you go. And when you hover your cursor on it, it actually tells you that the lower whisker, which is the minimum, is 18. The lower hinge, which is the first quartile, it's just different terminologies that Tableau is using, is 32. Median is 47. Upper hinge is the third quartile that Tableau calls it upper hinge, and then the upper whisker, which is the maximum, 75. Evidently, we don't see any outlier in the age. Age is one of those types of variables that you will not find outlier because it's always normally distributed. It's not like somebody lives 2,000 years or 250 years. Everybody is living between that 0 up to like maybe 120. I haven't looked at the age distributions. Where the standardized distribution of ages to look at what the age distribution look like, but based on this data set for the employees that work in this company, the age distribution is normal and we don't see any outliers. So that's one of the way. Let's look at another variable where we have some outliers. I think that would be discount percentage. And again, you will need to deaggregate it. And then use this. There you go. So this variables distribution has some good amount of outliers, and as you can see, the outlier once you hover your cursor on it, you can see the first quartile is 0, the minimum value is 0, the first quartile lower hinge is 0, and median is 0, and then upper hinge is 11, and then the third quartile is 11, and then the maximum is 27.50. So apparently we have a lot of outliers that exceed that maximum and the IQR that outside the whisker here. So these are the outliers that are available in this distribution. That was one of the way that you can create simply a box plot. Another way is to is pretty much to use using the feature on axis, and let's see discount. I think this discount percentages. So to deaggregate it, so simply right click on the x-axis and then click on Add Reference Line. While you're here, you can go to the Boxplot tab, and again, as I said earlier, 1.5 times the IQR is pretty standard in the statistics science. So 1.5 whisker extend to data within 1.5 times the IQR. So the whiskers would extend up to that IQR for the plotting of the outliers. And then the modern, you can play. Also, don't click on hide under underlying marks except outliers. Don't always leave that as it is, so you can look at the outliers. And then you can also play with the styles, and the borders, and also with how you would like the whiskers. Click on OK. There you go. Same thing as we did earlier. If you just make the size smaller, you can see. And the reason you see this line instead of individual plots is because there's a lot of data. There's a lot of data points in the distribution that makes it all clustered together and makes it look like a line. But these are all individual plot lines. And as you can see, we have great amount of outliers for this specific variable. All right. I hope that you had a good amount of knowledge about box plots and outliers and how you can use Tableau to identify and mitigate it. Thank you for your time.